Video, we are going to continue our discussion of vectors in 3-space with another application. So, a precast concrete wall is temporarily kept in its vertical position by ropes. Find the total force exerted on the pin at position A. The tensions in AB and AC are 420 pounds and 650 pounds, respectively. So, first thing I'm going to do is the picture overwhelms me. I want to see it like on a Cartesian plane. So, what I did is I put this point right here. And then I'm going to let this be X, this be Y, and that be Z. Now, you could have moved this around. I think when I first debated on doing this problem, I was going to put my Cartesian plane right there. But it made more sense because I realized in the problem, point D was never mentioned. Just A, B, and AC. So we're only going to deal with the right side of this. Now, if I'm going to deal with A, B, and C, and I'm dealing with these forces, I need vectors. So I need points. So using A, and if I'm letting this be my origin, right, then A is at 0x, because it doesn't go towards us or away from us. It goes to the right 10, and then it doesn't go up at all, so it's a 0. Let's do B first. So B in the x direction, notice this distance is 8. It doesn't go anywhere in the y direction, doesn't go left or right, but it does go up 6. So it's 8 in the x direction, 0 in the y, and 6 in the z direction. Now, the other side is a little tricky. You got to be very careful, and I almost made this mistake when I was first thinking about this problem, is this distance is not 8. It's actually 10 feet, and it's due to this. The whole distance was 18. It's not symmetric. It's 10. That's what's going to make this problem not split the force in half. Okay, so x direction, I go back negative 10. Y direction, I don't go left or right, and then I go up 6. So the first thing I would like to do is, I'm going to erase that, is create my vectors. This has nothing to do with the force yet, just a vector. So AB, that vector, and I just use those points, okay? So I'm going to use another color besides black. It's from A to B. We're talking about that vector right there. All right, so that vector is 8 minus 0, 0 minus 10, and then 6 minus 0, which is 6. All right, let's go ahead and do AC as well. So AC is this vector, there to there. That vector is negative 10, negative 10, and 6. Right, so these vectors are directions, but it'd be really nice, since I already have the force, if these were just unit vectors, because I could send the force in that direction, but only in one unit, meaning that my vector that's going to describe the force is going to describe direction, but the magnitude is also going to be correct. So I need to actually find the magnitude of both of these. To keep time short for this video, I'm going to go ahead and tell you what those are. Hopefully you can find magnitudes. So, and then the magnitude of AC is square root of 236. Kind of help us out work-wise. All right. Now, if I want to describe the vector that actually describes the force, okay, let's call F1 the force on AB. I'm going to take the force that was required, 420, and then I'm going to times it by a unit vector. So the unit vector is 1 over the magnitude. So I get that. Force, and then this is my unit vector. So it's sending the magnitude of the force in the direction of that vector, but we're going to make it a unit vector to help ourselves out to understand that that whole vector there describes the actual force vector. So that force vector is equal to, I'm going to give you guys the decimals instead of spending this time to plug them all in. I've already done so. So this is 237.6, negative 297 point, just no point, and then 178.2. That's that vector. Okay, F2, if we use the same logic, okay, it's 650, and then times the unit vector, 1 over 236 times the vector itself. All right, that vector decimal-wise, and these are approximations, so maybe I need to use those approximations there. This is negative 423.1, same number, 423.1, and then 253.9. All right, so there are my two vectors. I know that if I want to find the vector that is resultant from both of those pulling on A, the resultant vector we'll call F is the sum of the two. So that means I just add them component-wise, which means I'll go ahead and give you those numbers. If you were to add all those decimals, these, and these, X, Y, and Z, then we get negative 185.5, negative 720.1, and 432.1. That isn't the force. The force would be the magnitude. That's a force vector. The magnitude is about, with some rounding, it's about 860 pounds. So let's recap that really quick. I think drawing a picture with a Cartesian plane is crucial here. Me looking at the picture here above took me some time to try to think about it, but as soon as I threw it on XY plane, I'm like, oh, cool, I have points. I can make vectors. Then I can just make a unit vector and apply the forces and then add them together. Remember, a resultant force is always the sum of the forces on it. The way to get a force vector is to make it find your vector, make it a unit vector, and then times it by its force. And that will give you a vector that describes the force in that direction.